Good afternoon. I'm Dr. P. Usharani, Professor EEE S&H Department, RMD Engineering College. I am going to brief about the topic of mutual inductance. First, let me explain what is self-inductance, which is a property of conductor which opposes change in current flow. That means whenever current changes through a coil, they induce an EMF which is proportional to the rate of change of current through the coil. That is known as self-inductance. And mutual inductance. Mutual inductance is when two coils were taken, they are placed close together means the flux produced by one coil links the other coil. So in that we are going to find out the coefficient of coupling, mutual inductance, self-inductance. I have taken a problem of two coils, A of 12,500 turns and B of 16,000 turns lie in parallel planes so that 60% of flux produced in A links with coil B. It is found that a current of 5 amps in coil A produces a flux of 0.6 milliweber, while the same current in B produces 0.8 milliweber. Determine mutual inductance and coefficient of coupling. From the given data, they have given N1, N2, that is NA, number of turns in coil A, number of turns in coil B, they have given, and the percentage of flux produced in coil A, that is K times of phi A we have to take. Due to that, which links with coil B, the current is same. So the formulas for finding self-inductance, LA as NA phi A divided by IA, number of turns flux divided by current, and LB as NB phi B divided by IB, number of turns in coil B, flux produced and current. If you know LALB, we can find mutual inductance as K into square root of LALB. Here we can write from this equation we can write the coefficient of coupling as M divided by square root of LALB, or in terms of reluctance we can have the formula. This is just the basics, how we are writing L in terms of reluctance formula. L we can write in terms of N square divided by reluctance. We are getting the equation L as N d phi by di, or from the flux equation mmf divided by reluctance, that is N I divided by L divided by A mu naught mu r. Differentiating with respect to I means d phi by di, which is equal to I becomes 1 now. So N, this comes in the numerator, A mu naught mu r divided by L. I am going to substitute this d phi by di in this equation means L as N into A mu naught mu r divided by L, or N square into A mu naught mu r divided by L, or you can bring that in the denominator means it becomes reluctance. So the formula of L as in terms of reluctance we can write N square by reluctance. So we have two formulas, inductance, self-inductance. In terms of reluctance, the mutual inductance formula is Na Nb divided by reluctance. So now here we have one more formula for mutual inductance, that is some percentage of flux K phi A in coil A, the current at the time as Ia, which links with the coil B. We have to consider the number of turns in coil B. So if you want to calculate this M, we can substitute here and we can get the coefficient of coupling. So this K phi A as the percentage of flux in coil A which links with coil B. So given the data 0.6 as the given 60% of flux links. So I have taken the 0.6 and phi A is given in the question 0.6 milliweber. So converted into Weber. So 0.6 into 10 power minus 3. Number of turns is given 16,000 in coil B. IA value is 5 amps. So in the formula we have substituted K phi A NB divided by IA. After simplification, the answer for mutual inductance is 1.15 Henry. And the self-inductance of coil A as LA formula as Na phi A divided by Ia. So as per the given data in the problem statement, we are substituting the values 12,500 into 0.6 milliweber. So we are converted into Weber. 10 power minus 3 divided by current as 5 amps. The answer for simplification as 1.5 Henry. Similarly, we can find the LB, self-inductance of coil B, with the formula of NB flux B coil divided by IB. So I substituted the values of number of turns in coil B 16,000 into 5 as 0.8 milliweber. So 0.8 into 10 power minus 3 divided by 5, which is equal to 2.56 Henries. So I have calculated LALB so I can find the coefficient of coupling in the formula of M divided by root of LALB. After simplification, the answer is 0.586 Henry. Here the coefficient of coupling we can see, which is mutual inductance between coil is maximum when K as 1. That is M is equal to K into square root of LALB. In that formula, mutual inductance between the coil is maximum when K is 1. In the case of flux of one coil does not link with the other coil means K0. K0 means mutual inductance as 0. That's the inference of your coefficient of coupling. In this given data, we have calculated the K value as 0.586 Henries. Thank you.